Hi everyone, good afternoon. Thanks for joining me here for the session. So in this session, we are going to look into how openSUSE, especially openSUSE Leap 15.6 can be leveraged as base layer operating system for AI ML workloads containerization. So a little bit about me. I'm Rudraksh Karpe. I work as an LLM engineer at CS, and I was Google Summer of Code contributor back in 2024, and I'm contributing this year as well. So I'm especially passionate about the LLMs and advancements going around there and about the cloud native technologies. So let me tell you what is exactly Edge Analytics Edge ecosystem. It's the Google Summer of Code project where I worked in. So essentially, we have seen that running LLMs at the edge is something very interesting because using online LLMs, we are passing all our data to the LLM providers. So we are not caring about the data security, but what if we could process all the data on local, and with efficiency, we can do that everything on local, but the computation is the only limitation we have on the edge. So that's where the project started back in 2022. Back then, there were no LLMs. So my Google Summer of Code mentor, Brian Gartner, opened this GitHub issue, Analytics Edge ecosystem on openSUSE mentoring site for Google Summer of Code, and that's where this initiative started. So we initially, worked on core ML workloads, some, classification models and all, and those were containerized and deployed using SUSE Rancher. In his home in Utah, we had a home lab where we, set up KVM using openSUSE Leap 15.6 as base layer operating system. We containerized this AI ML workloads there, and we essentially, used SUSE Rancher to orchestrate. And especially we were doing all these efforts in the edge space. So we were using K3s, which is light version of Kubernetes. So that's how the name is K3s, like just K8s is 10 digits, K3s is 5 digits, so half of Kubernetes. So that was the entire concept. And essentially, in this project, we did a couple of things. You can see IT ops, AI ops, and platform engineering, because we set up the entire home lab there, and we set up everything using KVM, and I used to SSH from India into his system, and I used to deploy things from scratch, setting up VMs and all those things. That was a very interesting part. But back in 2024, when LLMs were rising so crazily, so we wanted to build a RAG pipeline, and we wanted to set up, essentially migrate this entire setup for the LLMs. And that's where we started putting the GenAI efforts, and that's how this concept came into the picture, like how we can leverage openSUSE Leap 15.6 as base layer container operating system. So yeah, I'll be diving into this ahead. So what is the essence of Edge? So this is just a basic comparison I'm doing here. So let's say there's a sky's the limit for the edge space. Let's say we can essentially process this. There are hundreds of use cases for this, especially in the retail space, even in the healthcare space. So, and one of the the finest one that we could find is the data security, because we wanted our data to be on-prem. So that's where my project will show how exactly we can keep entire data locally and run LLMs using Ulama as a local inference. So this is setup for the home lab we had in Utah at my mentor's house. So here you can see some host IP addresses and Rancher. Then we had K3s, RKE, and RKE2. Then operating system was openSUSE Leap 15.5. I think it's the old one. We are using 15.6 right now. And this is one of the pictures I got from him. So of this lab setup we had there. So then this is just workload and workflow diagram. So I'll be showing around a RAG pipeline. So RAG is essentially a retrieval augmentation generation. So we actually, let's say you have a document, and we will, chunk a text out of those document, and will pass that to LLM, and that entire thing will run completely locally. So here you can see I have this workload is divided into 3 components. I have a data pipeline, RAG pipeline, and user interface. So in this data pipeline, you can see like these are your files. Let's say you have some proprietary documents which you don't want to upload to any online LLM providers. So you can just completely keep it locally, and that data can be in any format: PDF, text, Markdown, even in Python files, CSV, Excel docs, or PPTs. Anything is fine. And I'm using like Llama Index as a parser. We can use multiple custom parsers, so like to parse data from that particular PDF file. So there are multiple open source libraries like PyMu PDF is there, and we can even write our own custom parsers. LangChain is providing their like PDF parsers and all. So I'm using Llama Index for my demo. And once we extract text out of those PDFs, then we will split that text into chunks. So chunking is happening here, and then we will perform a semantic search against that, and that will be stored in a knowledge base. So knowledge base can be your vector database. So here I'm using ChromaDB, and we are passing all this data to the LLM, and I'm using a simple Streamlit user interface. I will show ahead. And this entire workload is containerized in a Docker file, and we are using K3s and Longhorn as persistent storage. And if you want to build like some LLM ops pipelines around, you can always use Kubeflow, ZenML, or MLflow to or do some monitoring around. And this is completely managed by Rancher. So this is like workload, workflow, and Rancher-managed orchestration. So here is like a Docker file that I used. So like we are using openSUSE Leap 15.6 as base layer. Then Python is the core of everything. Then we have the zipper dependencies there, and this is a simple structure, but right now I have a very customized pipeline. So I'll show you in my code what exactly my current Docker file looks like. But in general, your Docker file will look like this for some generative AI setup using openSUSE. And this is, I just took a picture where, like some steps are happening while you are containerizing your application. So your zipper is downloading some dependencies and all. Then next to that, yeah, this is our basic stack, like SUSE Rancher. So SUSE Rancher is like Kubernetes management platform by SUSE, and K3s again is the lightweight version of Kubernetes. And we are using Longhorn as persistent storage in the process. And so how we can create a K3s cluster. So like there are multiple ways to create K3s cluster. Right now I'm on the Mac because I need computation. I am using M4 Pro to run local LLMs. So we can always get the latest K3s version from using some curl command there, and we can set up Rancher desktop. I have Rancher desktop here on my PC, so we can always use that. And we just need to do a couple of things. So I used to do it previously in KVM, but right now I'm doing it for the demo on MacBook. So I'll show you around how this exactly will work. In the demo, then we have this very common Rancher command. So you can run this, and Rancher will pull up in your UI. Next to that, I have a system architecture for my current demo. So I have a user interface right now. So my user interface looks like, let me show you around. Yep, this is how my user interface looks like. I'm running this app locally. So I have a user interface which is built using Streamlit. Here you guys can see And I have a K3s cluster. So if I go, so here is our K3s cluster. So in that I have a Olama service and my Edge Analytics app demo. So then I have a monitoring setup using Grafana and Prometheus. You can see I have Grafana and Prometheus here, and this is managed on the Rancher space. Then I have this Ingress, and an application layer. Again, I have this Streamlit app, so which is powered by the backend that I have written. So it's just Streamlit backend. I haven't converted it into any API, fast API or Flask as of now. And then the storage layer is again the persistent volume provided by Longhorn. We have then next to that. Let me just make it a slideshow again. Yeah. And then I have the data sources, like again, as I showed. So in the data sources, I have PDF, docs, text files, and all that. And we can run a live demo. Then we can upload file, then document loader. And I am using BG large embeddings. So embeddings are really important. So like when we have to perform vector search, so we need to convert that text data into numerical form. That's where the embeddings comes into the picture. So currently on the METB ranking, which is the popular ranking they provide for the embeddings, Tela embeddings are on the top, but I'm using BG large embeddings from Hugging Face. And again, I have vector store from Llama Index and query engine. So I'm picking top queries, and again, Olama local interface and LLM inferencing is happening here. So yeah, this is what I showed. So let's dive deep into the live demo, I guess. So here I'm uploading a hotel PDF of mine, which is I consider a proprietary document, something. So I don't want to upload this to ChatGPT or anywhere, and I want this to be completely localized. So I'm uploading it here, and I have uploaded it. So here you can see on my backend, it will say query engine created successfully. So right now, if I'm asking, where is Rudraksh staying in Amsterdam? So for this, I'm using Llama 3.2 model, which I shouldn't use because that's a big model. I should use Gemma, but okay, it will take some time. So I think we'll have to start. Okay, it is showing. So because Llama is a big model, Gemma is a lightweight model. So that's why it took a bit of time. So let's ask a follow-up question, probably using Gemma. And again, as I said, we are using BG large embeddings here. And I have two configurations. One is my K3s one, which is deployed on Rancher-managed SUSE, and one is local. So right now, if I run some another query here, can you tell me how much did he pay for his stay? And meanwhile, you can see here what exactly is happening in the backend. So it is still processing query. Okay, so it is showing price, the exact price I paid. So to verify, we can go and check how much price did I pay, whether it is correct or not. I think I'll go and try to upload some another document to show how exactly the indexing will be happening here. So probably I have this how to win friends and influence people, this book, and I'm trying to upload it, but right now it is adding this document on top of the previous document. So we need to restart it, and probably I'll do it again. So okay, so now it is reindexing it. So now here you can see what exactly is happening. The query engine is being created, document is being loaded, and right now we have the document here. Can you tell me the summary of the book? So again, the inference is taking time, even if I'm on MacBook. So, okay. Okay, this is very interesting because I think it is still picking the context from the previous one. So because the query engine is not refreshed. Yeah. I should do a refresh here. And I should pick Gemma. Then I should go to local again, and I should go to sources. Okay, I'm restarting the service. So meanwhile, the service is starting. Now I can restart it and I can run it again here. Awesome. Now it is creating embeddings again. So for new document, we are creating the embedding. So here you can see for that entire PDF, we are generating embeddings using BGE large model. So the entire text data, which is passed, is now converted into the vector forms, and these vector forms against which we will perform semantic query against the user input. So that's how the process will be working. So it will take some time because this is a large PDF I'm providing right now. So it's like a 300 pages of PDF, and out of which we can pick any edge model here. Currently it is still generating embeddings, so we can't choose the model right now. Let's give it some time. Okay, so now our query engine is created. So I can go and select Gemma as the LLM, and now I can ask okay. Okay, so now it is working against the book. And what are the top advice you will give to young people out of from this book? And this is pretty fast as well, so you won't feel like you're using some sort of local LLM. So, and this is a completely edge model. So there are some edge models like 5.3, 5.4 by Microsoft, and Gemma is currently the best one available on the Ulama site. We can always use ulama.com, and here's a list of all the edge models. So I'm currently using Gemma 3. Gemma 3N is also there. It's a multimodal model, so we can put some multimodality things as well, and we can run it on phone and everything. So that was it. So that was about the application part. Now I will go to the Rancher desktop, and I will show you how exactly the services are running. So in the Rancher space, if you see, I have this deployment here. So in this, if I open this, so these are running, and we can see everything that is happening. So there was a service I created actually while preparing for the demo. I created 2 services, and you will be able to monitor everything. So I needed to create a different service of Ulama. So here you can see why the service is not working or anything. You need to you essentially don't need to go through the app and debug through the logs, exec into the container and everything. You can see everything here on the Rancher UI itself, and you can probably fix this right here only. So I can edit YAML files, and I can just go here and fix whatever the issue is happening. So this is how Rancher is pretty helpful, managing all this Kubernetes or K3s clusters that we have, and that's pretty much of it about this project. So please let me know if you have any doubts or anything regarding this.
Any questions?
So that was all running on your local laptop right now?
Yeah,
and
no internet.
Did CPU load? Could you see it somehow how much it was loaded?
Sure. We can go into the activity monitor, and here you can see, if I can just, here you can see that Rancher desktop is taking, if I go into memory wise or CPU wise, when you use the NVIDIA one, right now I'm on this Mac-based like ARM, essentially NPUs. So when you use the NVIDIA GPUs, you can essentially run NVIDIA SMI command, and there it will show the real time the GPU consumption and all. So I didn't track it here, but when I was doing it back into our SSH-based service, we were using this NVIDIA RTX-based GPU, and there was a GPU node as well at my mentor's house, and we used to track that, but we were using 5.4 model by Microsoft, and we were always running out of memory. So, and in Mac, you can see it is working pretty seamlessly. Even apart from this, I have a bunch of things running here. 3-4 microservices are running, and it's working fine. I can load it. I could load the 300 pages PDF completely locally, and it worked as expected. So, so there is not an issue at all while running some edge models here, I think, with this. So, yeah. Sure.
Thank you for the presentation. I have a question. What made you choose Leap and SUSE Rancher? I'm pretty sure there must be some other alternatives. What benefits did you see in this? What made you choose this?
Sure, because to be honest, we could use any other operating system as well for the containerization, but openSUSE Leap is pretty stable. So if you see operating system like Tumbleweed, so Tumbleweed is always on a cutting edge update and rolling update. So that's why we choose Leap 15.6 as the operating system. So it was pretty stable, and for the edge use cases, because this was completely built considering the edge space. So for the openSUSE Leap has been pretty seamless to deploy on the edge and all. So my mentors were already working in that space, so they also recommended, and we could use that. So we chose openSUSE Leap, and for this K3s management. So we didn't want some big thing like Kubernetes. We wanted a light version like K3s, and K3s and Rancher works very seamlessly. So that's why we chose this stack. K3s Longhorn as persistent volume, and openSUSE Leap as basically operating system. Okay. Thanks, everyone.